Welcome back, Algebra 1, Section 2-2, solving one-step equations. And that's what we're going to do today. That's where our focus is going to be on solving equations using addition, subtraction, multiplication, or division. So we're only doing one-step equations, so there's only going to be one step to it, not multiple. That'll be coming up soon. But remember, when we want to solve an equation, we're finding the value of the variable. That's what we want to do. Get an answer, find the value. And our goal here, we use these terms a lot, isolate the variable or solve for the variable. They're interchangeable. Isolate the variable or solve for that variable. So we get an answer. And so we've all seen things like that. What we mean by isolate the variable, we've all seen things like this. And what we want to do is we want to get the variable, isolate it, or solve for it, get it all by itself. So we would add 7 in this case. And we'd end up with x equals 10. So it's all something that I think we've done before in pre-algebra. I think we've all solved the equations. And so we're going to do a lot of those things. Okay, we've got a lot of things here with our properties, and it's just kind of telling you why this works. So the addition property of equality, and the key term here is equality. Why does this work? So what we're doing here is we're saying you can add a value to both sides of an equation, and it will still be equal. So the idea behind that is if you, and I don't even think we need the symbols, that might just confuse you, but what we're doing here is we're just saying if you add something to one side of the equation, you can do it to the other side, and that will give you the right answer. So x minus 7 equals 10, or the equation will stay the same is what I'm getting at. So if I add 7 to both sides, just like we did in our previous example on the previous page, I have to do it to the other side as well. If I do that, then the equation stays the same. Because if I have 7 on one side, add 7 to the other side, it'll balance out. Think of it as a scale that wants to stay balanced. Some people like to draw a little line through the equal sign just to show, hey, they added 7 here. That means they have to add 7 there. Okay? The next one, subtraction property of equality. Basically the same thing, but it's just telling you that we're just using subtraction instead. You can subtract a value from both sides of an equation, and it will stay equal. So an example of that, and let's use another variable. Let's use b. B minus 9, or b plus 9. Let's go b plus 9 equals 2. B plus 9 equals 2. So subtraction here, again, if we do it to one side, we're going to do it to the other side. So if I subtract 9 from the left side, I have to subtract 9 from the right side as well. And just think about it. If I gave you 9 pieces of candy and then took them away, you would be stuck with the same as you had before. So we're just doing the same to each side to keep it equal. Multiplication property of equality. Same deal. You can multiply by both sides of an equation by the same number, and it'll stay equal. So one example of that would be, say, b over 6 equals negative 2. So if I multiply both by the same number, in this case, let's say I multiplied by 6, and I multiplied this by 6. If I do it to both sides, the equation stays equal. And then the division property is the same thing with division, to get rid of all these things. And it says if you divide both sides of an equation by the same number, then it'll be equal. So a lot of times what we see here is, let's say 9k equals negative 27. So in this case, if we divide by the same number on both sides, so if we divide by 9 and divide by 9, excuse me, not negative, by 9, then it'll stay the same on both sides. It stays equal, equality. All these equalities is why we do it to both sides, because then it keeps it same. If you do something to one side, do it to the other side, it'll keep the equation the same. Okay? And it's important to point out in this that we are using this with inverse operations. So what that means is when we take a look at up here, this 9, we talk about isolating the variable. So if the variable is k, if we're looking at 9k, okay, what's happening to the k right now? It's being multiplied by 9. So the inverse operation is divide. The inverse of multiplication is divide. So we're doing the opposite. It's being multiplied by 9, so we're going to divide by 9. Okay? The same with the problem right above it with 6b equals negative 2. or excuse me, it was b over 6 equals negative 2. Since 6 is dividing into b, or b is being divided by 6, what's the opposite of division? Multiplication. So in that case, we multiplied by 6. So I'm using the inverse operations. So when we talk about inverse operations, we're talking about doing the opposite. Do the opposite. What is happening to the variable? Let's do the opposite. If it's being added, then subtract. If it's being subtracted, add, and vice versa. Multiplication, division, division, multiplication. Okay, so we've done these before, but now we've already done this a few times, write an equation for the problem, but now we're actually going to solve it. Now we're going to solve it. So let's go down to letter C. I want to do this one. Okay, 12 is 1/5 of the number. Find that number. So we've all done this where 12 equals 1/5 of a number, which we can call x, and then we want to find the number. Okay, and I want to do this one for a couple reasons. Number one, because there's a fraction in it, and number two, because it's written a different way. Most times people enjoy seeing it from left to right. 1/5 x equals 12. There's no difference between these two equations. It's just one is written with the variable on the right, one with it on the left. So let's just focus with it on the left here to show that we can solve it. Okay, so when we look at isolating the variable, again, what we're trying to do is we're trying to isolate x. Well, what is happening to x? Well, it's being multiplied by 1/5. So the simple answer is to do the opposite. The inverse operation is to divide by 1/5, which you could do that, and you'd have to divide by 1/5 over here, because the principles of equality say you have to do it to both sides. Okay, you could do that, but when I see a fraction, I automatically think of the multiplicative inverse property, and I think, what can I do? I can multiply by the reciprocal, which might keep it a little easier. So instead of dividing by 1/5, I'm going to multiply by 5/1. Multiplying by the reciprocal is the same thing with the multiplicative inverse. But then I'd have to do that over here, 5/1 as well. Okay? And what you end up with, remember, is if we go multiply here, we'd get 5/5, which is 1. So all I'd have to bring down here would be the x. And over here, if I do this math, and I can do it in the calculator, I should get 60 over here on the left-hand side. Okay? Now, if you stayed with the division property, or the division way of just dividing by 1/5, just make sure you get it right. Just want to point out that you have to go 12 and then divided by 1/5 if you wanted to do it that way. Not 1/5 divided by 12. Make sure you get them in the right order, because these are not the same answer. You can check it in your calculator, but they're not going to be the same answer. So I always prefer just using the multiplicative inverse or the reciprocal when you see fractions, because it's a little bit easier to do it that way, and hopefully we know how to do that in our calculators as well. All right, the next step is these practice problems here, just the equations, and we're solving them and then checking our answers to make sure they're right. I'm just going to run through them. We're going to have to solve all of them, but let's just take a look at number 1 and what you would do here. It's m minus 48, so they're subtracting 48, so the inverse operation would be to add 48 from both sides, and then you could get your answer. Okay, how about number, and you guys can finish it from there. Number 3, how about number 3? We've got a little fraction, so what's happening to t? Well, it's being divided by 30, so we want to multiply by 30, and then we would multiply by 30 over here. So using canceling, these 30s would cancel out, so we would be left with t. And then if you can punch in your fractions in your calculator and find a way to multiply this, you should get t equal to 21. Or you could also cancel here and say, wait, 10 goes into 10 one time, it goes into 33 times, and then we just have 7 times 3. Same deal. Okay? And lastly, let's look at number 5 and say, okay, now we've got a fraction, and we also have a negative sign, so this becomes pretty interesting. Remember, if it's a negative fraction, you could put the negative out in front like it's written here, or you could write it as negative m over 3, or you could write it as, m over a negative 3. Doesn't matter, or you could keep it out in front like you had. Okay? Now in this case, I'm just going to use one of them, so you can write those all the same. But what I'm going to do is I'm going to make it the -3, and here's why. Because now when I try to solve this, I'm being divided by -3. So what I can do is I know that the opposite of division is to multiply. So I'm going to take this and multiply by a -3, and then multiply by a -3 over here to get my answer. And again, these answers, these numbers will cancel out. So m would equal -27. Now I want to point out that if I kept the negative up here with the m, and I just multiplied by a 3, well then I'd have the m would stay negative, and I'd have a positive 27 over here, and then I have to deal with that negative later and divide through by a -1, which is why I kind of wanted to keep it with the -3, because then I can just multiply by -3 on both sides. So we're just doing the opposite to isolate the variable. Okay. Okay, next, I think we've done these before, or we did them earlier today, so we can work on those. We can skip those, and that pretty much does it. So the lesson summary here is, what is it called when you undo an operation by doing the opposite? What is that called? We've used that phrase a handful of times. And then your practice problem is to write an equation and solve. A number increased by 5 is the same as 42. Find the number. So we're going to write that into an equation form, and then we're going to solve it. Okay? So that does it for section 2.2, solving equations, one-step equations, and bring stuff with you for class tomorrow if you have any questions, and we will get to work on this stuff.